Welcome to this lesson on finding the greatest common factor. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for today says I can find the greatest common factor of two numbers. So let's go ahead and talk about the vocabulary on the left-hand side of our notes. And the vocabulary word that we're going to talk about is GCF. GCF stands for greatest common factor. So let's go ahead and define each term. The word greatest means the largest of a set of values. So basically think the biggest or the largest number. Common means something that is the same. And factor means a number multiplied by another number. So for example, 2 times 3 are factors that make 6. So 2 is a factor and 3 is a factor that make a product of 6. So 2 times 3 are factors of 6. So now that we've defined what greatest common factor means, or the GCF, let's go ahead and talk about the key concept on the right-hand side. And the right-hand side says we're going to use the ladder method. So basically what the ladder method is, it's an upside-down division sign. So say we want to find the greatest common factor of two numbers that are 16 and the other number is 24. Let's take a look at 16 and 24 and place them inside of our upside-down ladder. And we're going to ask ourselves what number goes into both evenly. And the only thing I can think of would be 2 for now. There's other things as well that work, but I'm going to use 2. 2 goes into 16 8 times. 2 goes into 24 12 times. We have to extend our ladder again and ask ourselves what number goes into 8 and 12 evenly. And I can say 4 this time. 4 goes into 8 twice, and 4 goes into 12 3 times. We can break our ladder down again and ask ourselves what number goes into 2 and 3 evenly. Well, the only thing that goes into 2 and 3 is 1. 1 goes into 2 twice. 1 goes into 3 3 times. Once I notice that there's a 1 on the left-hand side of my ladder, that is my stopping point, that my ladder is done. But to find the GCF, we need to multiply all the numbers on the left-hand side of the ladder. So I'm going to take 2 times 4 times 1 and multiply them together. So 2 times 4 times 1 is 8. So the GCF of 16 and 24 would be 8. So this means that 8 is the greatest factor that 16 and 24 have in common. So we're going to skip this real-life slide for today, and we'll come back and discuss it in class tomorrow. So for example 1, they're asking us to find the GCF of 12 and 18. So in order to do that, let's go ahead and draw the upside-down ladder. And I'm going to place the first number inside and the second number right next to it inside of the upside-down ladder. So my job is to go ahead and determine what number goes into 12 and 18 nice and even. And I can say 3, because 3 goes into 12 4 times, and 3 goes into 18 6 times. So we can continue our ladder, and let's ask ourselves what number goes into both 4 and 6 evenly. So I can use 2. 2 goes into 4 twice, and 2 goes into 6 3 times. So now our next job is to ask ourselves what number goes into both 2 and 3 evenly. So the only number that I can think of is 1. 1 is the only number that can go into 2 and 3 evenly. So 1 goes into 2 twice, and 1 goes into 3 3 times. Notice we got a 1 on the bottom of our ladder, and that was our goal. So we know that our ladder is done because we have a 1 on the bottom. But in order to get the GCF, I need to multiply all the numbers on the left-hand side of the ladder and multiply them. So I'm going to write 3 times 2 times 1, because those are all the numbers on the left-hand side of the ladder. If I multiply them together, I get 6. So my GCF, or greatest common factor, of 12 and 18 is equal to 6. For example 2, let's go ahead and figure out the GCF of 36 and 48. And let's use that using the upside-down ladder. So I'm going to place 36 inside of the ladder, and I'm going to place 48 inside of the upside-down ladder. So let's think of a number that goes in nice and evenly into 36 and 48. So we can use a variety of numbers. I'm going to try 2. And 3 also works, but I'm going to try 2 in this case. So I know that 2 goes into 36 18 times. And I know that 2 goes into 48 24 times. Let's continue to break down this ladder. I know that I can place a 3 into both 18 and 24. 3 goes into 18 6 times, and 3 goes into 24 8 times. Let's continue our upside down ladder. And the number that goes into 6 and 8 is 2. 2 goes into 6 3 times, and 2 goes into 2 goes into 8 4 times. So now let's ask ourselves, what number goes into 3 and 4 evenly? And the only number that I can think of is 1. So 1 is the number that goes into 3 3 times, and 1 is the number that goes into 4 4 times. Now if you look at it, we've got a 1 on the left-hand side, and we've pretty much completed our ladder, because that was the end goal, was to get a 1 on the bottom. Once we've done that, we're going to have to figure out the GCF by multiplying all the numbers on the left-hand side. So let's take all the numbers and multiply them together. So I've got 2 times 3 times 2 times 1. If I multiply all those numbers together, I'll get 12. So 12 is the GCF, or the greatest common factor, of 36 and 48. So go ahead and pause the video and complete this got it problem, and we'll discuss the answers in class tomorrow. Notice there's 2 got it problems on this slide, got it problem A and got it problem B. So what you're going to find out is we're going to have to use the greatest common factor using word problems, or solving word problems. This word problem, for example 3, says a teacher needs to cut construction paper into equal sized squares. So no rectangles, no triangles, it needs to be a perfect square. The paper measures 24 inches by 36 inches, and this teacher does not want to waste any of it. What is the greatest possible length of each square piece? So what I will do, I will look for keywords. In this problem, I see the keyword that says greatest. If you see the words like greatest or largest, think greatest common factor. So we're going to have to find the greatest common factor of 24 and 36, because that's how large the paper is. So think of a piece of paper that looks like this. One side is 36 inches long, and the other side is 24 inches long. So let's ask ourselves, what can we divide this into? Or what number goes into 24 and 36 evenly? And I think we can use, let's try 2. 2 goes into 24 12 times, and 2 goes into 36 18 times. We can continue to break our ladder down, and the number that goes into 12 and 18 would be 2. 2 goes into 12 6 times, and 2 goes into 18 9 times. Let's add another layer to our ladder, and the number that goes into 6 and 9 evenly would be 3. 3 goes into 6 twice, and 3 goes into 9 3 times. Let's add another layer to our ladder. What number goes into 2 and 3 evenly? The only thing I can think of is 1. 1 goes into 2 twice, and 1 goes into 3 times. Notice we've completed the end of this problem because we have a 1. So we're done with our ladder. So let's figure out the GCF. Let's take all the numbers on the left-hand side, which is 2 times 3 times 2 times 1. And just like the last problem, we've got 12 as our GCF. So the greatest common factor of 24 and 36 is 12. So what this means is the square that the teacher needs to cut has to be 12 inches by 12 inches. So using the piece of paper that we've created, if I cut 24 in half, I get 12. So this is worth 12, and this is worth 12. Now if I cut 20, and I want to make sure that I have 12 going the other way, so this would be 12. So this is one 12 by 12 square. Here's another 12 by 12 square. Another 12 by 12 square. Another 12 by 12 square. 12 by 12 square. So if I look at that sheet of paper, this teacher can make 6 12 by 12 squares. For example 4, it says Bobby has 30 yellow thumbtacks and 75 red thumbtacks. Each bulletin board will have the same number of yellow Each bulletin board will have the same number of red thumbtacks. How many bulletin boards will Bobby have if all the tacks are used? So after looking at this problem, I'm trying to search for a keyword like greatest or largest, and I don't see it. But one thing that you can do is anytime it says somebody has to use all of the tacks or use all of something, like in this case it says he needs to use every single tack, I need you to think about greatest common factor as well. So don't just think about the words greatest or largest. Think of, is the problem asking you to use every single piece of information? So this one is. They want all the tacks used. So this is the greatest common factor problem. So let's go ahead and write it. 30 and 75. And we're going to use the upside down ladder to figure that out. So the number that goes into both, let's try 5, because 5 goes into 36 times. And 5 goes into 75 15 times. We can continue to add on to our ladder. The number that goes into 6 and 15 would be 3. 3 goes into 6 twice, and 3 goes into 15 5 times. Let's continue to add on to our ladder. And let's ask ourselves, what number goes into 2 and 5 evenly? And the only thing I can think of is 1. 1 goes into 2 twice, and 1 goes into 5 times. So if you think about it, we've done completing our ladder because we've got the 1 at the very bottom of the ladder. Let's figure out the GCF by multiplying all the numbers on the left-hand side. So that's 5 times 3 times 1. 5 times 3 times 1 is equal to 15. So the greatest common factor of 30 and 75 is equal to 15. So Bobby can create 15 bulletin boards. So go ahead and pause the video and complete this got it problem, and we'll discuss the answers in class tomorrow. So now that we've completed the lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and watch it again. Also, come to class with some questions so we can discuss it in further detail.